You know, something I like to do is go up to people who aren't technical and ask them what they think Linux is. I love that I'll get a different answer from everybody, but it's always something. As my brother pointed out, though, if you go up to programmers and software engineers, oftentimes they will always give you a different answer as well. I know this is somewhat of a copy pasta in the open source space, but Linux itself is not an operating system. GNU Linux is. GNU Linux is Linux as a kernel plus a collection of utilities called the GNU utils. And obviously there are different versions of this sort of system that you can create in order to construct different operating systems. For example, there is Busybox Linux. And there's also OpenBSD, which combines the BSD kernel with the BSD utilities. Today I'm going to be walking you through the Alpine Linux system, which is a flavor of Busybox Linux. Now, while that is different than GNU Linux, like Debian and its derivatives such as Ubuntu, it's similar enough that the principles that I'm teaching you will still work. So just keep in mind that while it may be a little bit different, this is a pretty good overview of how all Linux derivatives work. We'll be accompanied by my friend Tux here, who will be supervising and making sure that I don't make any egregious mistakes. And of course, if you notice me making any egregious mistakes that Tux here does not notice, feel free to leave some notes in the comments below. I'll be going through those. I'll also be answering any questions you guys might have from my limited expertise. Anyway, so when you boot up your computer, it is your BIOS's responsibility to choose what your boot device will be. So let's just say it picks a hard drive. It's going to read the very first 255 bytes off of that hard drive and then decide what it wants to do from there. Now, grub is technically part of the Linux kernel, but because obviously you might want to dual boot on a machine, if grub notices that you're going for Linux on a different partition, it's not going to boot the whole thing. It's going to close and then, it's going to continue booting Windows. So what we're going to do is we're going to put the bootloader at the top of this sheet of paper. And obviously I will be flipping this around so you guys can get a better look at it once I've added a few more things to this page. So let's put it up in its little box here. So grub lives in, according to the Unix system, under the /boot directory. So that's where you can go finding your grub or other bootloader configuration on a Linux system. Now, from there, it's going to load the rest of the Linux kernel. Now, something you need to know about the Linux kernel is that it is, in some degrees, blind and deaf. So you're not going to get, like you would with an MS-DOS system or derivative, a command prompt right away. What you're going to get is basically nothing. And this is by design. Linux's job is to execute a variety of other programs that will then allow you to access it and interact with it. And a key component of this is not only because it makes boot time shorter in some cases, especially if you're using an embedded device that doesn't really need a front end anyway, but it gives you options. And that is a key theme you're going to be noticing throughout this talk, is that just about any layer, any of these boxes can be swapped out for anything else, including grub, and including the Linux kernel itself. Like I mentioned, OpenBSD uses its own kernel, which means that even if every other level of this is the same, this level will be different. So your drivers actually live at this level unless they are user space drivers. So I'm going to be putting drivers here. Ignore the fact that I just put two S's there. I'll be putting a box around it. Hopefully that'll mitigate the problem a little bit. And these drivers will be essentially kernel extensions that will be interacting with the kernel and teaching it how to do things like interact with your hard drives, your monitor, your keyboard, your mouse. Obviously everything that you will need in order to use your system. That's why it's so important to be at this level. Now, what a lot of modern systems do is they want to execute what they call an init program. because obviously the kernel's job is to create processes and then manage those processes. It's the kernel's job to, once you've started a few programs, decide how it's going to run multiple programs at the same time. It's going to figure out how it's going to allocate execution cycles. Obviously, if a program crashes, it's going to want to take that program down. If your kernel crashes, the whole system goes down. But if a process that Linux has started has an error and it crashes, obviously your computer can continue to work, just because it's within user space. Now, older systems did not work this way, but most modern systems want to create what they call PID1. How does this get executed? Well, most modern Linux systems use something called System 5 init. And obviously this arose from Unix System 5, a distribution from back in the 80s when Unix was closed source and operated and maintained by AT&T. And you will find this in your //init.d. There will be a set of scripts or programs that will be executed by, it doesn't really look like a init, but you get the idea, by init.d. And this will do a couple of things. Most systems tend to start something like systemd. Alpine uses OpenRC, which is an alternative because systemd is a little bit controversial. Since systemd, for the most part, does seem to violate the Unix philosophy. Did I just write OpenD? I'm out of it today, man. I'm gonna just blank that RC. Just imagine that the first thing I put on this was OpenRC and not systemd. Okay, so you know what? Just note for the future. If I call it OpenD, systemrd, OpenRC, I'm all talking about the same category of items, but I am mixing the names of these applications because they use the same conventions. You know what? Let's just call it the init system. If I talk about these things, they just get jumbled up in my head. So this right here is PID1, right? And your Linux system isn't going to automatically connect to USB drives. It's not automatically going to set up a network connection. It's not automatically going to set up things like your display manager. So it's the job of an init program to handle a lot of these things. Now, back in the day when System 5 init was the only thing that you would have running on your system, there was sort of a convoluted system of lots of different scripts that would all run, and it would be up to the system maintainer to make sure that if any of these went down, that there was something in place to start them back up, and it got really complicated. So just about all modern systems use one of these. So what some people will do in their init script is they will also set up a TTY application. Now, a theme you're going to see very, very often is that this Unix systems were designed to be used as a computer that fills the room, a mainframe computer, that then communicates with independent terminal systems over a telephone line. So a lot of these programs are client-server models. And a big reason for why this is still the case is because obviously don't change what isn't broken, and we want to keep system compatibility for a lot of these older systems. But also there are certain advantages to using this model if you are going to be running Linux as a web server. It makes it really, really, really easy to get into the system and diagnose things. So TTY literally communicates over essentially telephone protocol. In fact, you can actually set baud speed in the setup of this application to communicate with the back end. So we use programs like Getty or aGetty. I'll put Getty next to this. I would have set up some kind of universal system for how I am displaying these, but because the Linux system architecture doesn't do that either, I'm just going to let this be crazy, just like Linux. If we were talking about BSD, this would be super duper organized. Anyway, so this TTY system, then we'll go ahead and usually set up a shell application. So if you've ever heard of Bash, or ZSH, which is what macOS now uses, or ASH, which is what Alpine uses, so shell. This is then executed here, and you will be able to access the TTY server through your shell application. Now, what the shell application does is it provides you a very thin scripting language on top of the existing Unix commands. Because for the most part, a large of what you do with SH is just general Linux or Unix commands, but it does give you a few more options. It also gives you some initialization scripts that you can use if you want to add environmental variables. For the most part, environmental variables aren't exactly part of the Linux kernel. They're actually a simplification that is allowed to you by this shell application. So if you're on a Linux system and you hit Control Alt and then one of the F keys, you will move aside into a different TTY instance. I believe about 6 tend to execute automatically when you first turn your system on. And you'll notice that when you run, when you hit these commands and you go into a different TTY, you will actually be kicked out of your graphical server and arrive at a command prompt-like interface. And this is by design, and it's super duper useful for diagnosing issues. Now, let's get into the fun stuff. Okay, so your display server. This is not as simple as I want to run a program that just starts all the windows and the taskbars and the window management up. No. Of course, it's Linux. It's got to be complicated. The Xorg system, which is what most systems use, was designed in the 1980s, and as I warned you about, is a client-server architecture model. So you've got this X server, right? And its job is to set up an environment for running programs from inside. And you don't actually have to have a display environment. In fact, if I wanted to host a single application over an X server, I could actually do that. If I wanted, for example, Chrome to be my only application and I wanted it to run full screen, I could do that. And then we've got this sort of network layer, and it communicates with different X clients. Put CLI here, CLI here. And this is actually useful in a couple of cases. For example, I don't know if you can see it back here. I'll show you. I got Minty back here, my iMac G3, and I had a Raspberry Pi. And so the way that I would use it is I would have the Pi act as an X server with a compositor, because keep in mind, Xorg was designed before graphics cards were invented. And this compositor program interacts with X server and then communicates over the network with your X client. I would have X client software installed on this computer, and I could essentially use it as a remote desktop solution. But just as is the case with the TTY up here, your computer is basically acting like it is both a terminal and a mainframe at the same time. So both sides of this will be running on your local computer. But that's the way Xorg works. Now there is a replacement in the works that has been in the works for like 20 years now called Wayland. And for the most part, it does have some support. It's just lacking quite a bit of driver support. So if you're using an NVIDIA card, you probably don't want to use Wayland. You want to use Xorg. Now the init application up here, typically this is done by the init application. It's not always, but sometimes it is. Its job is to then go ahead and start Xorg, which is our display program like we mentioned. Now from here, what it will often do is it will go down and start what's called a DM, or a display, I think it's a login manager. SDDM is a simple, popular one. I think Ubuntu uses it. You can install this pretty easily on Alpine. I use this when I'm on Alpine. And its job is to give you a graphical front end for loading different users in. Because keep in mind, Xorg doesn't know what programs to start. It doesn't know what window manager you want to use, what paneling applications you want to use. So its job is to start up the SDDM, and then SDDM's job is to have different profiles for different users, because you could potentially use different environments for different users, log you in, and then go ahead and execute the rest of the script. Now from here is where it gets a little bit crazy. Now I'm going to give you LXQT as an example because it's one I know pretty well. You can install it on Alpine without any issues. Lubuntu, not Ubuntu, but Lubuntu or Lubuntu uses LXQT. So what it does is it starts up the LXQT program, which then, you know, as it ought to, starts other programs. Now, one thing that people don't tend to understand is that your application is different than the window that surrounds it. Your window manager is a different application than the application itself. So the little border around your application, the X button, you know, the maximize, the minimize, those are a completely different application that communicates with your application via a protocol. Imagine that when you click and drag an open box, which is a window manager, an open box window, it then tells Xorg, hey, the user clicked on this window and wants to drag it to here. So then it goes ahead and moves the application itself over to that location. You do not need a window manager to run a graphical application, but it does make it a lot easier because if that application were to start any other windows, they would typically open without any borders around them, and that might be a problem. So LXQT is typically paired with, but it doesn't have to be, OpenBox. Keep in mind, because a lot of these layers can be rearranged, you can actually have your Xorg open OpenBox directly if you want to have it set up that way, or you can have your display manager open up OpenBox directly, but most people have it open up by LXQT or a similar environment system. And then LXQT will go through and do things like open up the LXQT panel. Keep in mind, the panel at the bottom of your screen with your start menu or whatever, I guess that's a Microsoft term, with your application menu, that is a program in and of itself that is then started by LXQT. All of the panel icons are programs that are started up by LXQT, and so on and so on. To the best of my knowledge, your mouse cursor is handled using OpenBox. So we'll put a little mouse cursor here so you can recognize that that's what that is. And then your update notifier, that's all from LXQT. If you have LXQT installed, you can go to your settings and then go through the auto login section and it'll tell you. Same thing with a lot of other systems like Unity with Ubuntu. That's the default under Ubuntu, I think. Although Unity does give you fewer options. XFCE, which is actually my favorite, does give you these options as well. And there's obviously a plethora of different things you can swap this layer out for. There's GNOME, Cinnamon, XFCE, Unity, blah, 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 blah. That's all going to be this layer right here. I'm pretty sure you can see, get this straightened out. Darn it. Okay, here we go. So we have all these different display managers and they fit in at this level. And then it's the job of the, well, not the display, it's the job of the desktop system or desktop environment to start up all the other applications that are launched after that. And it is from there, typically, then you launch your program. So let's go over this real quick. We've got your bootloader over here at the top, which then executes your kernel, which then executes the init scripts, which then execute the init application, which can be OpenRC or systemd. They're typically systemd on most Linux systems. It also starts off these extra sort of shell scripts here on the side. This then communicates with your X server or other display application, which then executes your DM, which then executes your desktop environment, which can be one of these things, which is reliant on OpenBox or a similar window manager to handle your windows. And then you've got things like your panel applications and such and so on. And that's where you finally get to be able to execute programs graphically. Now you'll notice there's quite a bit of quite a few things that start here, and now you might understand a little better about why it takes so long for your system to turn on. Keep in mind that there are a million other layers here that I haven't gotten into. For example, Ubuntu and other similar systems use a program called Nautilus, which is actually executed by your init program at the very beginning, and it's your loading screen. It starts up, like a little spinner wheel, and then the program closes when it's done, opening all the programs that it needs to for boot. And there's lots of, and obviously every single one of these things can be swapped out for something else, because of course you can. Linux is all about options. Finally, keep in mind that Windows doesn't exactly work this way. We don't exactly know how Windows actually works because it's closed source. It has a few things in common with this system, but not all of these things are going to exist in a Windows system. However, Mac OS, being a BSD, is a lot more similar to this sort of environment. All right, I understand that was probably drinking out of a fire hose, and I understand that my teaching style is a little eccentric and all over the place. So obviously, if I confused you, I apologize for that. If you have any specific questions, please, please, please leave them in the comments below. I will be happy to get to you and explain anything you might be confused about. With that said, I hope you guys have a great day, and goodbye.